Good afternoon, everyone, and thank you for choosing Across the Fence. I'm Will Michael in for Fran Stoddard. One of Vermont's premier wildlife watching opportunities has been on display in recent weeks. Steelhead rainbow trout have been making their upstream migration. It means leaping waterfalls in a spectacular display of determination. The trout are generally on the move in mid to late April and sometimes into early May. Across the Fence visited the rocky banks of the Willoughby River in the village of Orleans to learn more.
The Willoughby River runs through the village of Orleans, and also it flows into the Barton River. The Barton River flows out to Lake Memphremagog. In Lake Memphremagog, we have lots of different fish species, but one of them that is really kind of unique is what we call steelhead rainbow trout. When the conditions are right, you'll see them jumping out of the water. It gets anglers excited, but anybody, even if they don't fish, likes seeing these big, beautiful fish jump out of the water. It's a chance for people that aren't normally fishing to actually see a fish, and a big one at that. When the water is high enough, and when maybe the water's a little bit colder, they can actually swim up through and you would never see them. But it's only when the flows are at just the right level and the water temperature is warm enough for them to have enough, energy and strength to actually jump out of the water that you'll actually see them. We have many different species of fish in Vermont, some that are native, some that are introduced. Some of them are more tolerant to poor habitat or pollution, that kind of thing. These steelhead rainbow trout, the fact that these fish are there surviving, reproducing on their own is an indication that we have good water quality. The water's clean enough to support these fish, to support their entire life cycle from eggs to the juveniles and then out to the lake. So the fact that these fish can complete their entire life cycle in the Lake Memphremagog system and its tributaries indicates that we have good water quality and good habitat, which should matter to everybody, because if we've got these species surviving and thriving, that means that conditions are good for the entire ecosystem, including us.
That's cool. You got about 5.
Yeah, you think so? You got about 5?
Yeah.
What's the best way to see these fish, and what's your tips for seeing fish jumping, Judd?
Best time to go is usually going to be around late April, maybe into early May. You have to do one of two things. You have to get lucky and be there at the right time, or you have to put your time in, because sometimes you just go there multiple times and eventually you get it. Because these fish, they need the right conditions in order to jump, it can be hit or miss. But on a really good day, you might see over 10 fish jump in an hour.
For more information, visit the Vermont Fish and Wildlife Department's website. For decades, researchers at the University of Vermont have studied red spruce trees on Mount Mansfield. The species once threatened by acid rain, but a few years ago we learned of a turnaround. Rebecca Gollin explains.
The toll road in Stowe might seem like an unlikely place to find a news story. But there is one here, and it's good news.
What I found during that project was that yes, they've recovered, but the trees actually were growing better than they had in the entire record of their growth. Even a tree this size can be, 40, 50 years old sometimes.
Alexandra Kasiba is a staff scientist with the University of Vermont's Forest Ecosystem Monitoring Cooperative. She's talking about red spruce trees and a study she completed that produced some unexpected results.
So this was really surprising. We expected them to recover, but maybe just kind of go back to status quo. And here they were growing great, growing amazing. And so this opened up, this is how science and research happens. You stumble upon stuff a little bit unexpectedly.
To understand Kasiba's surprise, we have to take a step back and look at why red spruce was an important species in Vermont.
It was so valued that when Americans cleared the land in the 1800s to have hill farms and have sheep, it was the dominant tree that they were cutting out, building with, but also exporting. Burlington, as a timber mecca, exported a lot of its red spruce up and down the Lake Champlain through the Richelieu, etc. So it was a species that kind of loved to death.
Paul Schaberg is a forest health and productivity specialist with the U.S. Forest Service. He comes in to investigate when there are unexplained or unexpected changes in tree health.
Tree species suddenly starts to decline. The crowns are dying or its growth is going down, and we can't figure out why. It's not insects on the tree or something. Then we start doing studies to try to evaluate what's going on, why, and can we correct that?
Schaberg has been studying red spruce trees here in Vermont for decades.
Red spruce, from a human standpoint, is an amazing tree. It has a straight stem. It grows very well normally. It has very strong, lightweight wood. It's great for construction, but it's also really great for making musical instruments.
In the 1970s, researchers noticed that the red spruce that remained, mainly at higher elevations on mountains and hillsides, were dying. But that wasn't the only thing going on then.
That decline coincided with when we first realized that the precipitation coming down, rain, snow, and fog water, was very acid. This had been discovered in Europe, where industrialization happened much earlier and pollution standards were pretty much non-existent. But it was only with someone in New Hampshire at the Hubbard Brook Experimental Forest studying the water cycle, saying, "Oh, let's measure the pH of this," that they were shocked. It was hundreds of times more acidic than what they thought it should.
It was a puzzle for scientists at the time. They knew that the precipitation was highly acidic and that the red spruce, a formerly dominant tree in the area, was declining for no apparent reason. That's when they began to wonder if there was a link between the two.
Folks like Hub Vogelman at UVM started saying, I wonder if these are connected. And that began actually a tremendous scientific effort.
UVM professor of botany, Hub Vogelman, was crucial to the discoveries that came next.
To begin with, Hub, just how serious do you think the acid rain problem is?
Well, we think it's quite serious, and probably more serious than a lot of people believe today. Here's a picture I took a couple of years ago. It's at an elevation of about 3,000 feet on Camel's Hump. It's facing west toward the Champlain Valley. You can see a large number of dead trees, including mostly they're dead spruces.
The work of Vogelman and others led to the 1990 amendments to the Clean Air Act, which reduced the sulfur and nitrogen that were the main culprits in making the precipitation so acidic. But Schaberg was not done with red spruce just yet.
We kept looking at red spruce. So we actually, in the 1990s and early 2000s, figured out what was the mechanism. What was it about acid deposition that was reducing the cold tolerance of red spruce and making it susceptible to freezing injury.
It was the last piece of the puzzle about why the red spruce was so affected by acid rain. The key was calcium, which the acid deposition leaches out of the soil, leaving the tree more vulnerable to the cold. A massive winter injury event in 2003 further damaged Vermont's red spruce population. It was a few years later that Kasiba began the work that led to her study.
We were still looking at what we thought would be the downward trajectory of these trees that had been so badly damaged in 2003. And indeed, she found that the trees were growing much worse for 3 and even 4 or more years after that winter injury event. But she studied that far enough away from that big event that even though there was this decline for years, then the trees rebounded and they started growing better and better, so that they were growing the best they ever had in their entire lives. And that was shocking.
I was looking at that. Why is this happening? What are the climate, environmental reasons that could explain this growth? Is just happening in some plots? Is it because of our complex land use history? There's so many different factors that affect growth. And so taking a large number of samples, so looking at a lot of trees, over 700 trees, a large range of sites, so we're not just looking at one state or one location, so it kind of tears out all that variability. And then doing a lot of statistical processing, we can actually look at what climate or environmental variables explain that growth increase.
Working with collaborators from around New England and New York, Kasiba looked at samples from over 50 sites. She found that lower amounts of acid precipitation were pivotal to the renewed growth, along with the unique ability of red spruce to use the weather to its advantage.
It has this ability to photosynthesize in the winter when it's somewhat warm, when we have those January thaws, or it can take advantage of if we have a really mild fall and all the sugar maples and the red oaks have lost their leaves. Suddenly these conifers are just sitting there. Red spruce has this ability to then take advantage.
Well, this is certainly good news for the red spruce. The work of these researchers is not done.
We now have a remarkably good understanding of the trajectory and the niche of red spruce, a very important species, but red spruce grows in a forest with lots of other species. And one obvious question that comes up is, so red spruce is doing all right, what about these other trees?
It's a great story for right now. And we don't know what the future will hold for red spruce and for other trees in our forest, and that's why we continue to research these things and look at growth, look at physiology, look at how climate and environmental factors are affecting these trees, because we need to understand those dynamics to predict future changes and what will happen.
It's a good news story for now, but the ending still isn't written. And that's why these researchers don't plan to stop until all of their questions are answered. In Stowe, I'm Rebecca Gollin with Across the Fence.
And our thanks to UVM's Forest Ecosystem Monitoring Cooperative. And thank you for joining us. We know you have choices, so thanks for choosing us. I'm Will Michael, inviting you to join us back here each weekday afternoon for another visit Across the Fence.